Okay, well, let's look at this problem here where we are given a function and asked a few questions about it. Now, first of all, we're asked about the limit as x approaches infinity. So since it's a product, I'm going to look at the two factors and see what their characteristics are as each of them approach infinity. So for example, if I look at x squared minus 2x minus 1, we know that is a parabola, right? So even if we just make a sketch of it, and we could see as we approach infinity, the y value approaches infinity. Now that's being multiplied by e to the x. Well, e to the x, we know that sketch looks like this, right? And as we approach infinity, that's also, as x approaches infinity, the value of the function is approaching infinity. So the product of those two then, as x approaches infinity, the y values would approach infinity. Now, what happens though as x approaches negative infinity? Okay, well, if we look at the first factor, we can see as x approaches negative infinity, then the y value approaches infinity. But when we look at e to the x, as it approaches negative infinity, here, we know that it has a horizontal asymptote and that it will be approaching 0. So then the product of those two limits will be 0. Now for this question, you earned 1 point if you were able to get both correct. Okay, B. Part B wanted us to say when was the function increasing. So the function again was the quantity x squared minus 2x minus 1 multiplied by the factor e to the x. So in order for a function to be increasing, we always look at its derivative, and we want to find out when will that be greater than 0. So that means we need to take the derivative of f of x. Well, we know that to take a derivative, since it's a product, right, we have this first factor multiplied by the second factor, we're going to use the product rule. So the derivative of the first term is 2x minus 2, and then the second term stays the same. And then we add it to the derivative of the second term. Well, e to the x, the derivative of e to the x is e to the x multiplied by the first term. Okay, now let's simplify this a little bit. I noticed they have a common factor of e to the x. So I'm going to factor out e to the x, and what remains is 2x minus 2 plus an x squared minus 2x minus 1. So cleaning that up a little bit, we get e to the x squared minus 3. Now, we are interested as to when this is greater than 0. So let's set it equal to 0 and find the critical points. So we set each factor equal to 0. Now, e to the x, because we know that graph we just drew just a minute ago, we know that e to the x will never equal a 0. So this will not be one of our critical points. We set the second factor equal to 0. We get x squared equals 3. And then we take the square root of both sides. Now the square root of x squared is the absolute value of x. Some of you forgot this. So then x would equal plus or minus radical 3. Now we found the critical points, and we have to decide then at these critical points what's going on either side of negative radical 3 and positive radical 3. So this is an f prime sign chart. And so I'm going to find the sign on either side of these critical points. So negative radical 3, if I were to choose a value less than negative radical 3, let's say negative 2, and I substitute that back here into the original derivative. So negative 2 squared is 4, 4 minus 3 is 1, positive, and e to the negative 4 is positive, so it's going to be positive. Now let's plug in 0. Well, 0 minus 3 is negative 3 times a positive, so it's negative. And if we substitute a positive number, we're going to get positive. So we can see that this function is increasing on two intervals. So we would give a full explanation here. Now some of you, again, are forgetting to write out your explanation. So f of x is increasing on the intervals and it's from negative infinity to negative radical 3, union radical 3 to infinity. And why is it increasing there? Since f prime of x is greater than 0 on these intervals. Now remember, the sign chart is used to help us make a conclusion. The readers will not read your sign chart and interpret it for you. You have to interpret it. So since f prime x on these intervals is positive. Okay, now let's move on to part C. Now this was worth 4 points, just so you know. And to earn your 4 points, first of all, you had to get the derivative correct. That was worth 2 points. Secondly, you had to have the correct interval. So that's here, 1 point. And then your 4th point was your analysis. Okay, now look at the concavity. So we just figured out that the derivative of x was e to the x squared minus 3. So to find concavity, we always look at the second derivative. So again, it's product rule. So first term stays the same. Derivative of the second is 2x plus second term stays the same. Derivative of the first is e to the x. And so I'll clean this up. I notice they both have a common e to the x. So I'm going to factor out e to the x, and it's going to be multiplied by 2x plus x squared minus 3. So if I just put that in the correct order, because that's how I roll, okay, x squared plus 2x minus 3. Now we're trying to find out when this derivative is negative, so we'll set it equal to 0 and find the critical points. Well, looking at each factor, we know that e to the x will not be equal to 0. Now x squared plus 2x minus 3, setting that equal to 0, looking for that critical point. So that would factor to x plus 3, x minus 1 equals 0. So then my two critical points are negative 3 and 1. Now again, I'll use a sign chart, an f prime sign chart that is, to be able to determine where it's increasing and decreasing. So then I would substitute these points into f prime, and when x is less than negative 3, we notice that f double prime, thank you very much, is positive. When x is 0, then we notice we get a negative on f double prime. And when x is greater than 1, we get positive. So the question was, where is this graph concave down? Well, concave down is when the second derivative is negative. So we would say f of x is concave down on the interval negative 3 to 1, and tell me why, since f double prime of x is less than 0 on this interval. Now the scoring for this question is very similar to part B in that you get 2 points if you have the second derivative correct, you get 1 point if your interval is correct, and then you get 1 point for a correct analysis. Hope that helped.